So welcome back. Today, we'll be looking at another part of data ingestion. So before we learn more about Flume, let's study a little bit about the data loading issues, like data movement from other environment to Hadoop. So basically, we are having some issues with data loading into Hadoop. Okay, so like analytical processing using Hadoop, basically it requires loading of huge amount of data from diverse sources. Okay, and that too into the Hadoop cluster. And this process of bulk data loading into Hadoop is from different sources, and then processing it is it comes with certain set of challenges. Okay, so maintaining and ensuring the data consistency and ensuring efficient utilization of resources are some factors to consider before selecting any methodology. Sorry, before selecting any approach or for data load. Okay, so the major issues we face in productions are like data loading using scripts. Okay, so data loading through scripts are basically it's kind of traditional approach of using scripts, and using scripts to load data is not suitable for bulk data into Hadoop. Okay, so this approach is an insufficient and very time consuming. Okay, so if you are basically from SQL or Oracle, you might know about that. And another issue, the second issue, like we have there is direct access to external data through MapReduce application. Okay, so providing direct access to the data residing at external systems without loading into Hadoop. For example, for MapReduce application, the application so that approach is not feasible. Okay, and in addition to having ability to work with Hadoop can work with data in several different forms. To load large amount of data into Hadoop, different tools have been developed, and Scoop and Flumes are different tools for different scenarios. Okay, so we already know and we already saw what is Scoop and what is all about in the previous session. And I know that you session for practical as well. You will be getting the assignments most probably by tonight or tomorrow. You can have it for weekend. And see, like, so you guys have any questions on Scoop? Anyway, I have sent you a few articles and resources to Google Classroom. You can refer that as well. And I'm trying to send you some set of commands which can be used in Scoop and Flume as well. So please practice on your weekends. Step, as I said, like data ingestion will be the first step. Right. So let's move on to Flume. So today's topic is on the Flume. So working of Flume is like it's part of data ingestion. So we will know. So we will now look at another method for moving data into HDFS. Okay, and that is Flume. And after completing this topic, you should be able to describe what is Flume and how it is used with Hadoop, and obviously you can explain how it works. Right. So only 4 of you guys are there. So all right, let's move on. Let's jump into Flume further today. So you should note that the origin of the word Flume, it comes from Latin Latin via French. Okay, so the Latin word flumen or basically called as river, and the English word fume has a meaning of um of any open artificial water channel in the form of gravity chute. Okay, and that leads water from a diversion dam, or we are using a natural flow of downhill. Okay, and so fumes are used in transportation of logs in the logging industry. Okay, and the use of the word fume here is with the Flume software, and that's really metaphorical. And Flume in this world of Hadoop is used typically to transport web log records or database log records, but obviously not wooden logs. Okay, uh, so from the log files where records are deposited to a central repository. Okay, and this has been transferred to Hadoop distributed file system, that is HDFS, for analyzing by MapReduce programs or any other ecosystem, Hadoop ecosystem. Okay, so Flume is built on the concept of flows. Okay, so some of the features of Flumes are like Flumes are very flexible design based upon streaming data flows, and it is fault tolerant and robust with multiple failover and recovery mechanism. Obviously, Flume has different levels of reliability to offer best effort delivery system and end-to-end delivery system. So best delivery effort system is it doesn't tolerate any Flume node to failure. Okay, whereas end-to-end delivery mode guarantees delivery even in the event of multiple node failures. It can happen anytime. Okay, and Flume also carries data between sources and sinks. Okay, so you will get to know what is source and what is sinks later point in time. I'm not going to tell you now in a deeper level what is source and what is sink. We'll go with the flow. Okay, so basically this gathering of data can either be scheduled or even it can be event driven. Okay, so Flume has its own query processing engine, basically which makes it very easy to transform each new batch. Um, each new batch of data before it moved to any intended sync. Okay, so and it also possible for Flume syncs to include HDFS and HBase, uh, and Flume can be also used to transport even data, including, but it is not limited to network traffic data. Okay, so data generated by social media websites and email messages like that, and even for Twitter like that. So you can do a lot of basically we use Twitter for sentimental analysis to look at the people's opinion, and you know very well that Modi, I mean like in the past election, BJP has used big data for predicting their election results. So not only it's limiting to political, but you can use it for any product as well. So I'm just giving that as a tip because Flume has some relations with Twitter. Okay, so we'll look into that later point in time. So let's understand the Flume concept first. So take a look at this. It's a very simple images. We have agent and we have analogy. So agent has a source, and the next block is channel, and the next block is sink. You can relate with the second image here. With the it's a simple cable, but it has a lot of I mean like I can use that as a use case. So So there are basically many cases specifically where data is flowing from one location to another. Okay, and you have to handle that, handle all the flow of the data, and you can use Scoop for handling the data flowing to or from relational database. But when it comes to fast-moving unstructured uh, data, Apache Flume is needed. Okay, so basically what I'm meaning here is streaming data. Okay, so I told you like Twitter. So Twitter is, it's kind of streaming data, right? It works real time. You cannot I mean, like with a batch file. You can do that, but obviously you look Twitter for real time, right? So one of the use cases of Flume can be like moving logs into HDFS. So logs may be from your server, or whenever you run high traffic websites, you have more than one server running your web applications and generating logs like that. Okay, and you want to move these logs frequently to HDFS. Okay, or let's say like if you are running a web crawler which are downloading data from Twitter and other sources, and you want to move this data as when it comes to your HDFS or to your Hive. Okay, we'll look into Hive in the next topic. Examples of use cases could be like like I said, like you have multiple web application server running, and basically you're trying to generate and it's generating logs, and you need to move their logs at very fast speed, and you need to move it to HDFS to do a sentiment analysis, and you want to do download using crawlers in various data form from the Twitter, and then move the data to HDFS. Okay, so the basic philosophy of like creating various agents. Okay, so basically like each agent has three different parts. One is source, second is channel, and third is sync. Okay, so source basically it generates the data, and channel is the pipe. Basically it could be in the memory. Okay, and a sync is something like sync is the final destination of the data. These three parts are connected back and forth. So the source knows its channel source, push all its data into the same channel. Sync knows its channel, and the sync reads from the channel. Each sources separately. So in some cases, if sync is too fast at generating the data, wait a bit if the channel gets full. Okay, so channel is the memory supported queue on one end source of source, and it keeps on pushing the data into channel, while the sync is keeping on reading the bulk and pushing it somewhere else. Okay, so in this case, like sync is slower, and source is faster than the channel, and it will get full because it's very quickly. Like in case the source is slower and sync is faster, it will go empty. Okay, I'll tell you. I mean, like I'll explain you in a very clear form. So and source, what I mean source here is it could be like tailf in Linux. Okay, that means like that reads file continuously. Okay, and a daemon, or let's say a process is running at a particular port, listening for input packets to come in. Okay, so a source is something which generates you the data, and let's Okay, let's say like we launch a small service on a multiple machines, and we define that everywhere we are running on a port like 4444 so 4444 ports. Okay, so everybody who generates the log can connect to the source and put the data again. So Flume is essentially a distributed and reliable and available system. Okay, collecting and aggregating, moving logs from many different places to central data source. Okay, so the Flume supports a large variety of sources basically. So one is tail, and another one is syslog. I'll give you some small introduction on what is that. So tail is like it's same like what is how you use it in Unix tail hyphen f. Okay, and syslog is like the source of the data, which is data generation uh, person with the data. Data generation could be like based on system logs on Unix, or system log daemon in the process listing for the logs, and the whole system gives you all the errors or messages, error logs, or to any central processing. It keeps storing it whatever way it can be configured. It okay. And third one is like log4j. So if we create a log4j, it's a kind of service. Basically, it will basically help you to gather log from various kinds of servers, such as support log4j. Okay, can be arranged in arbitrary topologies, which means like source of putting data into one channel, and we could have sync pushing the data to anybody else source. Okay, which we can chain them together as well. We'll look into that a little bit deeper. So I put that into three different parts, how Flume works. See, um, the various source of data has sent through Flume. Maybe and maybe we have a different batching or a reliability setup like that. Okay, and it often logs continually being added to, and and uh, and, uh, and we want to like we need the new records as they are added. Sorry guys. So any number of Flume agents can be chained together, and you can be by starting a Flume agent where from where the data has been originates. Okay, and this data then flows through a series of nodes that are chained together. And every Flume agent works with source and a sink. Actually, a single agent can work with multiple sources and multiple sinks. Okay, sources are source and sinks are via, via channel. Okay, you can see that on the slide. So each node receives as sources and stores it in a channel and sends it through a sink. Okay. As an agent running on the one node, you can pass the data to another agent on a different node. Okay, so the agent on the second node can also work with sources and sync. Okay, and there are there are a number of different types of sources and syncs with the products. Basically, we will look into the sources a little bit deeper in the coming slide. I'll explain you what is source and what is syncs and all. So just go with as a layman. So I'll tell you, explain you each thing step by step. Okay. So there is something as consolidation. So like for data, it has to be passed from one agent to another. Okay. And we have an Avro sync here on the first, communicating with an Avro source on the second, right? So you can see that on the screen. So Avro is a remote procedure, and it's a remote procedure call, and the serialization framework is that it will be separate. It is a separate Apache project. Okay, and it uses JSON basically for defining data types and protocols, and it serializes the data in a compact binary format. Okay. So replicating and multiplexing is like basically Flume supports are more than just a multi-tiered topology. Okay, this is just an example of consolidation topology, and here is a single Avro source. Basically, it receives data from multiple Avro syncs. Okay, so both A and both a replication and multiplexing topology has basically supported, and it can be replicated as many as times. Okay, and in a replicating technology, like logs events from the source are passed to a channels and connected to that source. Okay, and in a multiplexing topology, uh, uh, data in the header area or area of the log event can be it can be queried, and it can be used, uh, and it can be distributed to the event for one or more channels. Okay, so we have seen how Flume works with Hadoop at a high level. In the next slides, we will look into figure and work with Flumes. Okay. So see, there are many chances in many cases, specifically where data is going from one location to another location, right? And you have to handle with the flow of the data, right? So you can use Scoop for handling and handling the data flowing to a particular location, or coming from a location, like let's say like any relational database. But when it comes to fast moving unstructured data, you need Flume. Okay, so as I started with what is Flume, so I'm just summarizing it. Some of you have joined very recently, I mean like a few minutes before. So Apache Flume is a system used for moving massive quantities of streaming data into HDFS. Okay, and collecting log data, presenting into log files from web servers, and it aggregates it into HDFS for analysis. Okay, and in one common example use case for Flume is like Flume supports multiple sources like tail, which pipes the data from local files and writes the HDFS via Flume. Okay, and basically it is similar to Unix command tail. Okay, and system logs, and obviously system logs, and Apache Log4j. So Apache Log4j is basically it enables Java applications to write events to the files in HDFS via Flume. Okay. So summary data flow in Flume, like, so know more about data flow in the Flume concept. Okay, so a Flume agent is basically a Flume agent is a JVM process which has three components. One is Flume source, Flume channel, and Flume sync. Okay, so through this after initiated at an external sources. Here in the screen in the slide, so the event basically generated by external source, right? So basically that's a web server, and it's our consumed by a Flume data source. Okay, and the external source sends the events to Flume source in a format that it can be recognized by the target source. Makes sense, right? So Flume source also receives an event, and it can store it into one or more channels. Okay, and that's one of the feature. So the channel that acts as a store, which store, and it keeps the events until it can be consumed by the Flume sync. Okay, file system in order to store these events. Okay, and Flume also Flume sync also removes the event from the channel and stores it into external repository like HDFS. Okay, and there could be multiple Flume agent, and in which case, like Flume sync forwards the event to the Flume source, and of course the next Flume agent will be in the. Okay. So also and unit of data flow is having a byte payload and optional set of string attribute, guys. Okay, so Flume transfers from the event of its origin to one destination. Okay, so and it also optionally headers, and it can also can be added as a part of an event. Okay. So what else? Yes. Yeah. What are the components of Flume? See, as I said like earlier, like Flume have three main components. Okay, so one is source, second is channel, and third is sync. Okay, and with this slide, second is channel, and third is sync. Okay, so we'll look into that a little bit detail. So basically, source. So source is see, source is an active component which the end receives the event and place it into the channel. Okay, and channel is a passive component, means which buffers the event and sends it to the sync. Okay, and the sync is which writes the data into next hop or the final destination. Okay, so here is some example, guys. Example for configuration. So here name the component of this agent, guys. I hope this is visible, right? All right, so see a1 dot source one. So this, see, a1 is my agent name. Okay, and a1 has got the sources and sync and channel basically. Okay, and we could put the sources as r1, or let's say like a1 r1 c1. Okay, So anything like, so similarly we can put sinks as HDFS sync, HDFS cluster 1 sync, and HDFS cluster 2 sync, and like that. Okay, and channel is mostly like the channel one, where you can also have multiple channels. Sometimes we might have one channel which is there in memory, and there is another channel, for example, like C2, mirror image of data on the disk. Okay, so if the sync fails to read from C1, it will start reading from C2 and try to get the data. Okay, so that makes sense, right? So we just gave the names to source and channel. Now let's describe each of them. Okay, so then the next one is describe or configure the source, like a1 dot source dot r1 type equal to netcat, binding it, and then we are mentioning the port. So here r1 is a type is called so netcat is a very quick way to create a process that listens to a certain port. It binds on a local host at port at the mentioned port. Okay, so here I have mentioned the port 44444. Okay, describe the sync. See, see a1 dot syncs dot hdfs hyphen cluster. Okay, so I'll tell you I'll show that in practicals. But anyway, like let me explain what describes the sync. So here the sync type is HDFS because we are trying to listen on the local host at a particular port. Okay, and whatever data we read from there, basically we are going to push it onto HDFS by specifying the HDFS path. Okay, and that's a particular folder in HDFS. Right? Makes sense, no? So let's describe the channel. So take a look at the channel. Okay, so here channels type is a memory, and its capacity is 1000 bytes. Okay, and transaction capacity is 100. Okay, so now we need to tell our sources that which one is your channel, and to our sync that which one is your channel. So let's bind the source and sync the channel. You can see that in the bottom of the screen. a1.sources.r1.channel equal to c1, and okay. So basically like the agent needs to know about its sync. Okay, and it needs to know about the source channel as well. So similarly, like source needs to know about its channel and sync. Okay, and it needs to know about its channel as well. Okay, so it needs to know all the channels and syncs, and they are just trying to collaborate. Okay. Guys, if you're not able to understand, please, I'll be sending you this project is basically Apache project, and you can refer from the flume.apache.org link as well. For deeper level, you can learn from there as well. Okay. And how it configuration is like see. So follows a hierarchical configuration which follows the key value pair. File have many agents, but only named agents are loaded. There are some set of basic rules here. Okay, so every agent must have an at least one channel, and every source must have at least one channel, and every sync must have exactly one channel. Okay, and every component must have. Okay, so make sure that these rules are set. You can set for an agent. You can set multiple channels, and for sources also you can mention multiple channels. But in sync, you must exactly have one channel. Okay, so that's the rule, and every component must have their own type. Okay. Event driven. Read data from the clients and sync. See, here sources are like it can be event driven. They read data from clients and syncs. Okay, and they stores events in the channel, and supports batching and sources like fan outflow and interceptors. Okay, so the external source basically it sends the events to Flume in a format that it can be recognized by the target Flume sources. Okay, for an example, like an Avro Flume source, it can be used to receive Avro events from any Avro clients or other Flume agents. Okay, or let's say like the other Flume agents in the flow that sends events from another Avro sync. Okay, so Flume provides supports for various source types, basically with its built-in API. Okay, a few of the basic source can be like I can tell you a few API sources. Avro source, then spooling directory source, syslog source, netcat source, executive source, then HTTP source, Twitter source, like that. Okay, so the source basically has the responsibility of delivering the event to configure the channel. Okay, and all the other aspects of the event processing are invisible to the source. Okay, so let's see what is netcat source. See, netcat source can listen on any given port. Okay, and it converts each line of data into an event. Okay, in let me tell you two different netcat source. Like one could be like netcat TCP source. Second one could be like a netcat UDP source. Okay, let me give you some favors on netcat TCP source. See, a netcat is like source that basically listens on a given port and turns each line of text into an event. Okay, and it acts like nc hyphen k. Basically, uh, um, that's host, and hyphen p is the port, that is the argument. And in other words, like I can tell you, like it opens a specific port and listens for the data. Okay, that makes sense, right? So the expectation is that the supply data in a new line, yeah, data is basically in a new line, and it's separated text. Okay, and each line of the text is turned into a Flume event and sent through the connected channel. Okay, and basically this is for the TCP. Okay, and for the UDP, like uh, see, as per the original netcat TCP source, this source has this source was basically that listens on a given port and turns each line of the text into another event and sent through the connected channel, and it acts like host and port. Okay, and it could be like nc space hyphen u space hyphen k space hyphen l, like that. Okay, so moving on, let's say what is Xsource. See, executive source, basically it runs on a given Unix command on a startup, and it expects that the process to be continuously produce data on a standard out. Okay, so let's say standard derive is simply discarded, and unless the property log standard errors is set to true, it will continuously produce the data on a standard out. Okay, and if the process exists for any reason, the source also exists, and it will continue to produce with no further data. Okay, so this means basically like it's a configuration such as like cat or tail, and it's going to produce the desired result where like date and named as pipe or file, and it will be probably not the former two commands, but it produces the streams of the data, whereas the later produce a single events, and it will automatically exit. Okay, you can I'll tell you this one. Let's see what are the few slides. Summary channels. Right. So see, channels are basically it's a communication bridge, and it's between source and sinks. Okay, so that's within one agent. Okay, source receives an event, it will store it into one or more channels. Okay, and the channel is passive stores that keeps the event until it's been consumed by the Flume sync. Okay, and memory channel, basically like it stores the event from an in-memory queue, and from there events will be accessed by sync. Okay, see, because of software and hardware failures, if an agent process dies in the middle, then all the events in the currently will be in the memory channel. Okay, and that are lost forever, right? So that's how the system works, right? So the file channel is another example. Like it is backed by the local file system, and it's unlike memory channel or file channel that writes the contents to a file on the file system that is deleted after any successful delivery to sync. Okay, so Flume provides supports for various channels by default, and I can tell you some examples of channels like memory channel, file channel, JDBC channel, pseudo transactional channel, then spillable memory channel. Then so basically like these are few examples for uh, uh, for a channel, but you need to make a note that the memory channel is the fastest, but risk of data loss. Okay, and the file channel are typically much slower, but effectively provided guaranteed delivery to sync. Okay, so this is one point of interview question about memory channel. So moving on. So data to the next hop or destination always attached to a single channel. See, sync basically it removes the event from the channel, puts into the external repository like HDFS to the file source of the Flume agent in the flow. Okay, and within the given agents runs asynchronously within the in the channel. Okay, and by default, like Flume provides supports for type, and I can give you some examples. Like HDFS sync, thrift sync, Avro sync, IRC sync, logger sync, null sync, HBase syncs, obviously. So Morphle and Solar sync, then Elasticsearch sync. So these are just an example. I'll give you some overview on HDFS sync. Basically, it writes the events in the HDFS in the form of text or sequence file. Okay, and it can also provide provides kind of support compression. It can support compression and can make for dynamic path like file or directory. And about the file role ring sync, it stores the events on a local file system. Okay. HBase syncs of syncs there. Okay. One is HBase and another one is async base. Okay. So this is one point of interview questions, like how many types of syncs is here in HBase. Okay. And another one will be async base. Okay, so it can basically it can write events to HBase incrementally. Okay, and HBase configuration is picked up from like HBase hyphen symbol. Basically, it will be in the configuration file. Okay, I can give you some detail on the Elasticsearch sync as well. It's good for as of now. So apart from this built-in components, we can also create our own custom sources and channels and syncs, basically like through Java. Okay, and we can deploy them into Flume. Okay, so we can. What I mean is like we can create our custom syncs, channel and sources. Okay, so channel selectors can be like it can be replicated. It can be replicating channel selectors. Selectors, and it is by default. Okay, and it can be a multiplexing channel selector to custom channel selector. So here in sync, basically another concept is there is sync processor. So basically this sync groups it groups to allow users to group multiple syncs into one entity. Okay, so sync processors can be used to provide load balances and overall syncs inside the group. It can achieve failover from one sync to another case, but it's of basically temporal failure. Okay, And sync processor types could be, say this is very this is interview point of question is sync processor types. Four types. So one is default sync processor. Second is load balancing sync processor. Failover sync processor. Fourth one is custom sync processor. Okay. Some concept like interceptor. It can modify, drop. It can modify or drop any events in the flight. Okay. So there are some say there are some concept called timestamp interceptor. Okay. Basically, it inserts a header key timestamp whose value. Okay. Something is relevant to timestamp. Okay. So another one would be like a host interceptor. So basically, it inserts the host name or let's say IP address that agent is running on. Okay. And another one would be like a static interceptor. It basically appends a static header with a static value to all events. We have UUID interceptor, Morphile interceptor, to it, but just for your knowledge. And we also have regex filtering interceptor. This one is basically like regex filtering interceptor. It filters events by selectively and by interpreting the event body as text and matching that to a configured regular expression. Okay, and we also have regex extractor interceptor. So you can find that in the Apache Flume.apache basically you can find in the Flume guide. There is another main concept here in the sync which you need to see is like sync processor. As I said, like into a single entity to provide the load balance or failover capability. Okay, we can write our own sync too. Please go over that in the link. You can refer that as well. Okay, so here's the link, https://org. So you can find the guide from there. Easy and very easy to understand because the concepts are very in a very simplified way. So let's recap, guys. So Apache Flume is an agent for data collection, used for log data. Flume basically Flume takes data from several sources like Avro, syslogs, and other files, and it delivers to various destinations like Hadoop HDFS or HBase or Solar or somewhere, right? So Apache Flume is also composed of 6 important components: sync, channels, sources, receptors, and agents. Okay, so I'll give you a quick recap on that. Like the data units that are transferred over a channel from source to sinks, and the size of the events are usually 4 KB. Okay, so this is one point of certification questions, like what will be the size of the events usually. So the event size should be usually like it's 4 KB. Okay, and sources is basically they accept the data from a server or an application. Okay, and sources also listen for events, and it can write events. Okay, and since we gone over that, but since basically it receives data and stores stores it in the HDFS repository, and it transmits the data to another source, right? So the basically the write event data to a target and remove the event from the queue. Okay. Next one, channel. So this is also important component, channel. So this channel component basically it connects between source and sync by queuing the event data for any transaction. Okay, and interceptors are basically they are also an important component, and they are used for dropping data or transferring the data as it flows into the system. Okay, and the last I think event source syncs channels. Did I told you agents? Agents. Okay, so agents are used to run the syncs and sources in the Flume. Okay, so far so good, right? We'll look into the practical session. Unfortunately, guys, I'm running up with time. The meeting in by 9:30, so I need to work on it. The practical right away. Send you a separate invite tonight, and show you the and also I will add it to the Google Classroom. Okay, and before we end up this session, we have the last topic, high-level comparison of Scoom and Flume. Okay, see, you guys should be thorough with Scoom, right? And you must be knowing a little bit about the Flume as well. So I would request you to review this video once again and look into it, because whatever I have mentioned is it's all in true perspective. And if you are through with this concept, I told you in a very simplified way, might be for understanding, but if you go through the concept once again through the video, it will be like very useful for you. It should be very fruitful for you when you're facing interviews. Okay, so let's go to the final topic for the day, Scoop versus Flume. So Apache Scoop is something, it's basically designed to work with any type of RDBMS, okay, and which has the JDBC connectivity. And Apache Scoop can also import data from NoSQL database like MongoDB, Cassandra. Along with it, it also allows data transfer to Apache Hive or HDFS, right? But in Flume, it basically works pretty well in streaming data sources that are generated continuously in Hadoop environment, such as log files. Okay, and Scoop, it can load Apache Scoop. Basically, it loads. Load is it's not driven by events. Okay, and in Flume, Apache Flume data is loading is completely on event driven. Okay, Apache Scoop also has a connector based architecture, which means like the connector knows a great deal in connecting with the various data sources, and also can fetch to the data which is correspondingly. Okay, so in Flume, Apache Flume is has an agent based architecture. That means code written in Flume is known as the agent, and that will be held responsible for fetching the data. Okay, and the difference.
It's 9 o'clock.
And the difference would be like Apache Scoop will be considered as an ideal fit for if the data is being available in Teradata, Oracle, MySQL, PostgreSQL, or any JDBC compatible database. Okay, but Apache Flume is considered the best choice when we are talking about moving bulk streaming data from sources like JMS or spooling directories. Okay, and Flume is in Flume, like data is set to flow with HDFS through the channels in Apache Flume. Okay, in Scoop, for importing the data in Apache Scoop. Okay, and else like, and Apache Flume is also specifically and aggregating data. That's because of its distributed, uh, reliable nature, and because of its highly available backup routes. Okay, it has a high available backup routes, guys. Okay, but in Apache Scoop, it's specifically used for parallel data transfer. Please note that it's used for parallel data transfer, and data imports as it is the data pretty very quickly. Okay, Scoop also has a connectors that are designed specifically to work with the structured data sources and to fetch the data from any of the connectors. Okay, and they are very they can fetch data from them only. Okay, but in Flume, it's specifically designed to fetch streaming data. It's from Twitter or log files from a web server, or let's say application servers, anything. Okay. So far good, right? I mean, like, that's the main points for comparison. So guys, any questions so far? Now, all right. Yeah, says no. Any questions, guys? You can the chat window. I can do that. I can reply you now. Okay, Sedu Raman says not getting it fully, but we'll watch the video again. Back to you. Good, Sedu. Brinda says need to go over think video again, Karthik. Okay. All right. So like yes, I mean, like it's bit difficult for you to understand the first shot, but once you go over this video once again and go with the Apache guide, it will be like it will be like a pancake. So the concepts are very easy, guys. So please go over the video once again. I'll send you a separate invite for practical, maybe tonight or else by tomorrow. So you can expect the assignments. I'll be sending you for Scoop and Flume as well. So far good, right? All right, guys. Any questions? You can mail me or call me back. I can clarify on that. Okay. So or else interact with the Google Classroom. Right, guys. Thank you so much. See you in the next class.